31, and here is Emmett, who's going to talk us through Symphony Compass and Apache Lucene. Over to you.
So my name is Lucene. I work at Lehman Brothers in sales technology group, so I'm quite interested in sort of rich, reactive web apps. So I'm quite interested in search for some months now, and had my eye on using Compass for quite some time. So I guess to sort of set out what we're talking about, we have the first question is why search, what's the big deal? Secondly, we're looking at very briefly at the options, and then sort of going through Compass and hopefully looking at a rather trivial example of how you can use Compass. And then finally, any questions? So, why search? Well, in essence, it's why not? Google, in particular, have shown the importance of search recently, and to the extent that they've kind of really changed the way a lot of people use the web. Like, I know a lot of people now who actually just type the name of a site into the Google box on their web browser rather than type it directly into the search box. You know, that strikes me as an example of how search has become so ubiquitous and so permeates their way of thinking that I just search for it. And you see, that sort of way of thinking it then becomes an expectation of users, because if they can do that in their web browser, why with their web application can't they do that? So it's an expectation thing, and also it is ubiquitous because just to give you a small example, here we have Spotlight, which is now a standard feature of OS 10, and it has a similar feature in Vista, so I can start typing.
Is OS 10 Leopard?
This is Leopard, yeah.
Excellent.
But it's been there since time. So, but so it's been available for the last kind of 2.5 years.
Mm-hmm.
It's right there. It's always on the screen. So here, it searches. It gives you applications, it gives you definitions of words. If I type in 1 + 2, 1 + 3, it'll give me the answer. This shows how search is ubiquitous, and it becomes a part of the user's expectation of application. So if you don't do search now or soon, then the users are going to be disappointed and frustrated. So that comes on to the second point, which is users don't want to navigate. As I said, they'll type into Google and splurge up and they'll get the information they want. And the other way of looking at it is that users shouldn't have to navigate, because the classic model of learning applications is that users are trained, right? Okay, you go to this menu, you click this option, and you go to here, and then you can look for accounts, or go to this other place and you can look for customers, or go to this other place and you can look for orders. Well, that imposes a kind of conceptual kind of barrier to entry on users. There's a whole bunch of things they have to remember. With search, they can be much less structured. It imposes far fewer assumptions on them. They can just kind of be far more. They can just basically waltz right up your app, type something in, and get a meaningful result. So it can make users more productive and increase their engagement with the applications. So that being the case, well, to step right into the detail, think about how you implement search in your application. And in your classic, simple sort of SQL-driven application, you'll end up with something like that, or you'll end up with, more likely, about 1,000 lines of stuff like that. You'll end up with Scrox or SQL generation, or maybe even using like ORM tools, you'll still end up with a whole bunch of that, and you'll also be tightly defined. Because when you're searching for customers, you're just searching for customers. You're not searching for customers and other stuff. You need to kind of know in advance what it is you're looking for. So, partly due to the nature of the relational model, you basically you have to know in advance pretty much what you're looking for. And it doesn't really work because tightly defined relational data doesn't really work. If you start trying to union between customers and orders, well, because they're two different things. The columns aren't in any way comparable or kind of related. So you can't do that simultaneously unless, of course, you start doing stuff like you spawn multiple queries off to do all the different types of things, and then you end up doing something that's really rather complicated. So that means that if you have a requirement to be able to search all these different things, you've got a big headache in terms of your application, because you're going to have to implement multiple threads searching for different things, and then somehow figure out how to collate the results in some kind of meaningful way and display them to the user. So unstructured search can be something of a pain in a classic application. Now, obviously, there are ways around this. So what are the alternatives? Well, I suppose I'll confess here, I'm not really going to give a huge range of alternatives because realistically, for text search, there pretty much aren't many. Certainly in the open source world, there are some commercial products which aim to be enterprise search. I mean, perhaps the most famous of these is the Google Box, which is this idea of a search appliance. It just sits on your network and sucks up data and applies Google's algorithms to it.
What did you call that? The Google Box?
Google Box.
Box, okay.
It's kind of black box solution that they provide you, which again, that's very aimed at web content. So that's about enterprises indexing their intranets, and it's also, as you might imagine, not at all cheap. There are other enterprise products like UltraSeek, which aim to do this sort of thing. Now, again, it's not cheap. I think enterprise licenses are something like $25,000 to $50,000 for unlimited search. So, not something you're going to be buying for your bedroom project. So, to come on to the alternatives, enter Lucene. Lucene was developed around about 1990,000 by Doug Cutting, who was asked by his wife to come up with a tool for building cooked recipes, indexing her recipes. And as he happened to be really rather good at information retrieval theory, he ended up building this product called Lucene, which was aimed at solving the problem of textual search. Lucene, has anyone used Lucene? Yeah, okay. So Lucene is, as they're pains to remind you, Lucene isn't an out-of-the-box search engine. Lucene is a set of tools for building search engines. It's a low-level API, so it's about indexing data. It doesn't really care what the data is, and basically just being able to get at that data very quickly. And I suppose the key point to come back to is textual data. That's Lucene's focus. That's what Lucene is very, very good at. So Lucene is important to just about anything. Sorry.
When you say textual data, do you mean text in files in the directory, or do you mean something in the database?
Well, Lucene doesn't care. That's one of the abstractions. Is that Lucene doesn't care where you got your text from, as long as you give it some text and it's like index this, right? And we'll come on in a second. Come on to like the structure of Lucene index, but basically, yeah, Lucene is about taking gobs of textual information and just splitting them up into tokens. So basically, in the loosest sense, you can think of those as being words. They typically are words. So, for example, if you ask Lucene to index a sentence, the quick brown fox jumped over the lazy dog, it will split it up into seven tokens. So quick, brown, fox, and what it will also do is it will filter out certain words because they're like in English, the word the appears in just about every sentence and therefore is fairly meaningless from a search perspective. So it discards words like that. They're called which are called slot words. And it does basically a whole bunch of data. It can do a whole bunch of data cleansing and arrives at all the words or tokens which are meaningful for that document, and then just indexes them. So it knows that if you have 10 documents and that term appears in 3 of them, it creates a very effective, very efficient data structure so that you can find those 3 documents. Okay, so I was kind of getting ahead of myself there a bit, but basically Lucene, the point is it's used by just about everyone. It's been ported to just about everything. Microsoft even had a product which was based on a .NET port of Lucene. They may well have ditched it, I don't know, but it was an Outlook search product which was bought by them. It scales. This has been proved time and time again. I recently done a project for which we used Lucene and Compass, and it was kind of who's who database, consisting of about 1.4 million names and biographies, and around 1 million companies and biographies or descriptions of those companies. So all in about probably 9 gigs of text in a very large set of database tables. We were using Lucene. We were able to index that and return search results within a maybe 1-2 second time frame. That's including rendering the USP. So performance is unquestionable. So we have Lucene. Base Lucene is very useful, but it's an API. It's like JDBC. It gives you access to data, but it doesn't necessarily help you do higher levels of things with data. So there are a number of products which build on Lucene. First of which is quite an interesting one, Apache Solo. It is actually a search engine built on Lucene, as in something you can fire up on a server and it will go away and crawl data and enable you to index that data. And it's if you're looking for a standalone product, it's quite an interesting one, though it's fairly new. And so that's more like a kind of Google Box search appliance approach. It has built-in document handlers for most of the reasonable common document types, and you interact with it with an XML-based interface. I guess one thing I thought I'd better mention is that there's Hibernate Search. Now, I guess it's coming out from a different end of the market. This is much closer to what Compass is, and it's obviously coming out of the JBoss camp, and it is very similar to Compass, but it's specifically designed to build in with Hibernate. So it's about giving you a transactional search cache over your Hibernate data and exposing it to full text search. It has quite an interesting JMS-based clustering solution, so that you can have a master-slave setup So if you have a Hibernate, have a cluster of boxes running Hibernate, you can have one of them being designated as the index master, because indexing is computationally expensive. So you maybe don't want to do that on all of your boxes. One thing about Hibernate Search though is it's relatively new on the market. It only went 3.0 final a couple of months ago. So as yet, it's not that feature rich, and certainly compared to Compass, it's not really there. And also, I suppose it is focused on Hibernate, so your mileage may vary.
Excuse me.
Yeah.
Can I interrupt you? I think transactional in that sense means that the search results you get obey the transaction isolation level.
Yes, basically, that's an important, very, very important point. Good question. I mean, basically, the idea of a transactional search then is that the state of the data should represent the transactional state of the underlying model. So, if for example, you perform an update, or several updates within a transaction, it will update the indexes, and then it will commit them at the point at which you commit your underlying Hibernate or whatever transaction. So this means that the search data represents the committed state of your application.
So basically you do not need to synchronize your database and your search.
Absolutely, yeah. Because the whole point of this, the transaction sync, is it's done transparently for you. And this is one of the things that Compass is very strong with. So, Compass is mainly done by this guy called Shay Bannon, who is a very good developer based in London. Don't know much about the guy, but well done. It is an abstraction over Lucene, but it doesn't aim to get away from Lucene. So it provides you, at all times, it tries to provide you with access, if you need it, back to the underlying Lucene indexes and searches which back the Compass framework. And I suppose the other real standout feature with Compass is that it provides some ORM style mapping. So it's about mapping and marshalling your domain model to and from Lucene indexes. Lucene provides nothing like that. So in that sense, it's a big kind of gain over Lucene. It also provides rather useful Spring integration, because Spring is pretty ubiquitous. Pretty much everyone's using it. So, I mean, the Spring integration in sort of, I guess, three ways. Firstly, it provides nice wiring for all of the beams. It allows you to configure all of your Compass setup using Spring config. It also has Spring MVC controller for doing searching, so we'll see that a bit later. And obviously, it provides interception for managing the transactions. So, I mean, I think we've already talked about Lucene and what it is. I suppose what we can do is just sort of here's an example of a document. A document consists, a document is the core, but is the only data structure really in Lucene. A document can be viewed as, it's kind of like a table, kind of like a SQL table, except it can contain dynamic fields at a runtime. It's a kind of arbitrary user-defined collection of fields. You can put in it whatever you want. So this example is a rather contrived one of what you might index from a web page. In this case, all of your base are belongtous.com. So we've just got a document identifier, which would be a record number, the title. We'll have the URI that we searched it, we got it from. We have a multi-valued field called links, some keywords, date, and the content, the actual full content of the document. Now, one thing to reiterate is it's all text. There is no other actual data type in Lucene than text. You can treat things and marshal things to and from other data types, but fundamentally it's all text. And what Lucene will do is a process of parsing and analysis, where it will split these up, like the body content up into its constituent words, or basically into its constituent terms, and discard the ones which are irrelevant, and keep the ones which are. So jumping on slightly, this is the kind of the life cycle of what you do with Compass.
But on the previous slide, what are the fields? You know, your last bullet, the fields can be single valued.
Yeah.
So in the document, where are the fields? Is the job title?
Yeah, these are all the fields.
These are fields.
Yeah, so these would make up the Lucene document. So it's just the Lucene document is the sum of all the fields, and each document will have some or none of these fields, yeah.
And what's the result of the search? A document or a field?
The result of the search is always a document. Again, a good question. Yeah. When you search in Lucene, it will return the matching documents. Basically, it will return an array of all the matching documents. Okay, I can actually work up and do this. I can show you. It's a very useful tool if you work with Lucene called Luke. Which you can get from getopt.org/Luke, getopt.org/Luke, or again, if you just punch Lucene into Google, you'll undoubtedly get it. But so here is just again, I'm slightly jumping ahead of myself, but this is an example of a Lucene index. You can see it has some fields down the left. So this in this case is, I trust you're familiar with the pet clinic example that we all know and love, because I'll be using this just to keep it nice and simple. I was going to present a slightly more knowledge-driven example in terms of data volume, which would be the CDDB database. It's about, I think it's about 500,000 CDs, but I never got around to writing the parser for the data format.
For the benefit of people who don't know what the pet clinic, that's the J2EE.
Yeah, sorry, yeah. It's the kind of the standard sample application. I'll talk a little bit more about that, but just to kind of just to give you a taste of what a Lucene document is like. We have some fields. As this here is just telling me what the top matches are. You know, so the word owner is the most common term in this index. And so in here I can browse through the documents. There are only 9 in this index. But here we can see that. So here's what the fields values are for this pet. Sorry, this owner. So we got first name George. So last name Frank, telephone number, and so I can just demonstrate. If I search now for George in first name, search, you get one result. So if I just go back to my
So that is a Lucene index file visualizer.
Yes, Luke is a wonderful tool. It's invaluable when working with it. I mean, even if you weren't working with Compass, you can actually. It's very interesting because any application that uses Lucene has a standard binary format, unless they've done something very custom. So you can actually. I think you could probably point that at the indexes that Jira produces, for example, or Confluence, or Fisheye, or any number of heavily Lucene using applications. You can inspect their data and play around, but also, in particular, when you're developing your own applications, it's invaluable because you can get right down there and see what's been actually indexed. And test out searches and just play around with the data. It's a brilliant tool. I think
when you say index, do you mean index the database column?
No.
Index primary keys and things like that. Primary keys.
No, I mean just to kind of backtrack. The Lucene index is basically it's everything. So the Lucene index can be, you can imagine, is so say I had like 9 documents like this. The Lucene index is just a file containing all of these 9 documents. You can think of it as being a SQL table, right? Could be, or it's not a terribly good analogy, but.
So an index is a collection of these documents?
Yes, that's right.
Okay.
So it doesn't index each individual word to help researching for the occurrence of the word within. You have a collection of documents that are indexed.
Yeah, absolutely. This is what it does is it builds a binary data structure over the as it analyzes each document. It figures out which terms appear in which documents and then stores that as part of the data structure. So yes, basically. Now I think the last thing is this idea of virtual fields. Now this is actually an incredibly powerful concept, and there's not really anything like it in. In SQL. I mean, imagine if you would, right? So we've got our sort of customer table in a classic SQL thing. We have a customer ID, first name, last name, address, telephone number, five different discrete items. And so if we're doing a classic SQL search, we just all them together, where, like, or, and the performance of that becomes quickly very slow. Imagine, though, that you could have a view over that thing which represents just the concatenation of all of those fields. I think you could do that and see, almost no one ever does. Partly because of the difficulty of code, because you have to convert all the different data types into a particular script representation. Part of what makes Lucene so powerful is that you can very easily create a virtual field over everything, every single data item in the record. So I can create a field called all, which will search everything in body content, creation date, keywords, links, URI, etc. And this is fundamentally how Compass works. It will by default search the virtual all field that it creates. So if I go back to Luke, I can show you this in action. So you'll see there the structure of the index. What it creates is a .cfs file, which is a compound file system file. It's just a condensed binary file, and some other files like statements.j, which basically just because Lucene will create any number of files, and then it has this file to say which files it has. Anyway, and that's all easy. So you see here, Compass, because this index has been created by Compass. It has this field called OR, which doesn't actually exist, but has been created from all of the underlying data. So I can actually search this field, OR. So if I search for George in OR, it produces the same match as if I searched it specifically in the first name.
Lucene itself doesn't have that.
Well, Lucene has obviously Lucene supports this because otherwise it wouldn't work. But Lucene by default doesn't do that, and whereas Compass does that for free, and just you don't have to worry about it. Okay, I mean, just a very, very obvious kind of life cycle of, actually it's come up a bit dark, of how you work with Compass. So the development time activities, you kind of do the mapping. You figure out what you're going to map, what you need to index, and then you create the mappings. I'll show you basically two ways to do that. Then at runtime, you'll do the indexing, which builds the indexing, and then obviously you'll search those indexes. Then on an ongoing basis, data in your application changes, so you mirror it. So I guess we'll look at each of those things in turn. So mapping. Well, I think we've established quite comprehensively that we can map Java classes. Come on to that. Interestingly, you can also map much less structured data. So you can map JDBC tables, for example. You can give Compass a query or a stored proc, and you can say map the results, index the results.
What does some of the acronyms mean? OS?
Sorry, yeah, this is the Compass own acronym. So OESM is Object to Search Engine Mapping, and then Resource to Search Engine Mapping, and then XML to Source Engine Mapping. So yeah, with the resource mapping, you can basically just any kind of stuff you can think of throwing at it, you can throw it in. And with the XML mapping, you can basically have it map XPath. So you can use XPath to extract bits of your XML and throw it into the index, and it basically works. I mean, I think the main use case really for Compass is the first one, but there are important examples where you typically want to do the mapping of JDBC queries. For example, on my recent application, we had this very large amount of data which we just wanted to index. So I just gave it a stored prop name and said, okay, we'll map the 5 resulting columns, and that was it.
But how do you build that?
Sorry?
It's a one-off operation, isn't it? You build the index from the results set at that point.
Yeah, no, I mean that's again a good point. Yes, indexing is a one-off kind of is a one-off bulk exercise, I suppose. We're just yeah, indexing is runtime or pre-runtime construction of the indexes which will be used. So it is, you know, it's like select star from whatever, you know, It's taking a whole bunch of data, all of your data, and munging it into them to build the initial state index. Okay, there's a kind of navigational theme running throughout Compass. So the index providers are called GPS devices. So, but yeah. But coming back to the So mapping classes, you've got really two choices. You can go with annotations. Sorry, yeah.
When you started this, you said what items were being mapped. It was Java classes, data sources, and XML. What about all the data in the database? You know, suppose if you have an application that's running, and you said it says providing traditional search capability, and you want to make it a little bit more advanced, right? So in that case, if you introduce Compass, there is already data in the database.
Yep.
So do you still go through the same process of mapping Java classes?
No. I mean, like I said, the option 2 is resource to search engine mapping. So a resource can be anything. A resource can be a result set, if you like. So in that case, if you have a database which you don't necessarily map onto a Java domain class, then sure, just basically pass in the query name, pass in the query into your Compass configuration file, and just say execute that, and it will come back and iterate over the results set and throw all of the results into the index. So yeah, I mean, absolutely, you can do that. So, if you're fortunate enough to be using Java 5, you can go with the annotations approach. If you've used JPA or hybrid annotations, it's very similar, and I would imagine typically you use them together. So, I think the two, as with JPA, the two kind of key things really are the searchable annotation at a class level, and the searchable ID. That's kind of the bare minimum that you need. And then for all the columns that you want to make searchable, you annotate them with searchable property. Because Compass doesn't take the view that you want to index everything. Unlike Java persistence, where you typically want to persist everything, you usually don't want to index everything because there's some things you're never going to want to search on. It's not tin thing or not tab. So here we have a name. So we've got this simple class called author, and it has the author ID, name, and birth date. So here we're marking the ID as being the primary key. We're saying the name is going to be searchable, and it's going to be searchable. It's going to be indexed as a column named name. And then we're indexing a date, but because we have to convert it to a string, we need to specify a format. Compass by default will use a long ISO data format. So it will do it in reverse order, so you can do lexicographic search. So it will do year, month, day, hour, minute, second, etc. So that you can do a prefix search, 2000, where date starts with 2006, and it will bring back all. So the annotation stuff it's fairly straightforward if you've used annotations, and again very much like JPA or I don't know. What you can't see here is it supports two notions of relationships between objects. You have references on one hand and you have components on the other. An important distinction because Lucene indexes, as we know, are flat. they're just, it's a flat data structure. There's, you get n records, and each record has a number of fields in it, just like a SQL table. And obviously you can't have any kind of joins or anything like that. So there are two ways you can map this. You can have a reference to another record, or you can embed the contents of that second dependent record in this record. Basically add extra fields. It supports both approaches. But I won't talk too much about that now. So basically, that's the same mapping done as XML. It's fairly straightforward. Again, I think it draws heavily from Hibernate in terms of its mapping style and influences. Okay. Sorry, that's actually I should draw that. There's an important design decision in terms of what you store in your index, because Lucene has the ability to basically analyze the term and then just store the results of the analysis, or it can store the results of the analysis and the underlying text that got it. So if you had Quick Brown the fox jumped over the lazy dog, it can store that and the offsets of all the different words. So Quick Brown fox, etc. Obviously, when you have large indexes, so if you're indexing 9 gigs of text, your index is going to be 9 gigs plus if you store that fully uncompressed. So Lucene supports index compression. So you can store the full text at around 30% of the size. So I mean, it doesn't indexes scale very well. So it doesn't actually make it that much slower if you've got a 9 gig index. It's just a 9 gig index, so it becomes a storage management problem in terms of space. So, coming back to our indexing, I think we've covered this. We've got GPS devices. Out of the box, Canvas provides GPS devices for Apache, Hibernate, JDO, and JPA. There's also a JDBC resource, basically a query executing thing, as I kind of previously described, that executes queries and index the result set. The index structure. Now, what Compass does is it allows you to search across these different types of thing by modeling them as Lucene sub-indexes. And I suppose one way I can show you what that looks like is just go to the directory structure. Index directory. Within index we have sub-indexes, and the default strategy is to create a sub-index per Java class or entity in the broader sense. So in the pet clinic example, where there are 4 Java classes which are being indexed. So pets, owners, vets, and visits. And so they're all stored as separate, and each sub-index is a fully functional Lucene index. So yeah, this kind of illustrates that within each index you have these little segment files, and these segment files can be arbitrarily large, and there can be any number of them. So they can scale up kind of indefinitely. So, searches are they're an array of Compass hit objects. And if I perhaps a better example is to go to the actual API. So the compass here provides quite a very simple interface. So you get the alias. The alias corresponds to the sub-index, or to basically the alias is synonymous really with the class name in the case of mapping objects, or with the table or result set name in the case of mapping resources. We then have two kind of really important methods, which is get data and get resource. Get data returns you the Java class if you mapped it with all of the fields hydrated from the index. So if you index first name and last name but not address, it will return you your Java object with first name and last name populated, obviously not address. So it will attempt to hydrate all of the index properties in the class. Finally, for resource, that returns you an abstraction over the Lucene resource where you don't have a class to map to. The score is an important one. That's Lucene's sort of query score, which is typically a number between 0 and 1. 1 being a sort of perfect match, 0 being a negligible match. The final method actually is highlighting, which is about basically parsing the text of any number of fields and producing markup, showing highlighting text like Google style markups.
You said we can index Java objects, JVC result sets, XML objects.
Yes.
And get data will return
Java objects.
a Java object.
Yeah. Get resource will return anything else.
Okay. So if it's an XML document with index,
then you will get resource. And then the get resource it will return. You can then get the it's effectively a map. So you can then do. So if we look in Luke. If we're looking at Luke, you have a field name. If it's been mapped as author name, if you resource get author name, it will return you the value of that. So, I guess, coming back to the pet clinic example. So the pet clinic is the sample which is distributed with Compass, so you can go and play with it. Apart from being a trivial application, it's interesting for two reasons. First of which is that it demonstrates how you can map a kind of a simple but fairly typical kind of object model. Pets have owners, vets have specialties. Owners have visits. So you have collections and a fairly simple kind of object graph. So the second reason is interesting is because there's actually not one line of application code devoted to Compass. So it demonstrates how Compass can be added to an application with no code. I suppose just to show you what the application is, it's not very exciting. So we have the welcome page. So we display all veterinarians. These will be familiar from the thing here. And we have find owner. Shows me all the owners. So Schroeder. So if I search for Schroeder, should get that back, and that's mapped. So I suppose we'll just briefly look at the mapping. So if here are all our domain classes, and here is the XML mapping from our domain classes. It's slightly complicated because this is using common metadata. So he just to illustrate the point, he's done some inheritance over the mappings. So we have this base class of entity which guarantees that it's going to have an ID, and then with name which has an ID and a name, and then with person which extends entity and maps first name, last name, address, city, telephone, etc. And specialty. And so, I mean, if we go kill the loop and get back to it. If I go to the index, you'll see that these are exactly the fields that are in the index. Okay, and so that's the mapping. And the other piece of configuration is the Spring config to set up the compass instance, which is so we have all of this stuff is standard Hibernate Spring stuff, and then below it, where it says compass start, we have an instance of the compass beam, and then we tell it where. I mean, again, it's very much like a Hibernate session factory. You tell it where to get the mappings, you register some settings, you bind it to the Spring transaction manager. Then we have some a GPS device. So that's the Hibernate GPS device, which provides basically provides a synchronization between Hibernate and Compass, and it can just ask Hibernate, give me all the entities, and then it can just index them. And it will also perform mirroring by using Hibernate Hibernate event listeners, so it knows when stuff changes in Hibernate. And this is just a wrapper around it.
So does that mean that this Hibernate integration takes care of all the data management? It does the initial index?
Yeah. I mean, the initial index you have to basically you'll have to call the index method on the beam. So you'll have some piece of application. You'll either have use one of the standard controllers, or an application code that just goes, goes compass.index, and that will ask all of the GPS devices it knows about to do the initial index.
That's bootstrapping. It's kind of you do that once.
Yeah.
Okay.
Yeah, and you have bootstrapping, and then ongoing. That's really it, because the event listeners will deal with all the rest of the data updates. But yes, so really the application integration is pretty much that, right? And then also for the search, we're using the standard provided Spring MVC controller, which Compass has, which I believe is search. So here you see we have two controllers, an index controller and a search controller, which are all out of the box, which are both out of the box compass. Out of the box compass. So you don't need to write any code to do this. And the rest of it is just is the actual business logic, the application code. So to integrate Compass in this rather trivial application was a case of adding in two Spring MVC controllers and a couple of Spring beams. And then what's quite interesting is if you look at the actual search results page, it kind of illustrates the way in which you interact with the results. So this is. So let me just recap. This is what it looks like. So it provides links to the underlying different things. So it could be an owner, it could be a pet, it could be a clinic visit, it could be a vet. And the way that's implemented is a simple kind of multi-value check to see when. So if it's a pet, you need to display the pet name. If it's a visit, you need to display other fields. So you have to handle all the different things that you're going to be displaying. So for a pet, you want to show a link to the pet edit page, etc. I mean, so this is about as complex as it gets in terms of dealing with search results. You just need to have cases to deal with all the different types of entities that you're going to be displaying.
You could also do instance of from the data object, because it is a pet object, isn't it?
Hit.data will be hit. So the hit object itself is an instance of compass hit, and then hit.data is going to be an instance of object which is whatever type you've marshaled. And I mean that's kind of, so here with one JSP and a bit of config, we've got added sort of global search to an application. So that's now obviously in real world scenarios you probably want to write a bit of code to do some glue, to do some utilities. Like for example, out of the box, this doesn't do highlighting, and highlighting is something you usually want to do. But highlighting, but to feed highlighting, you need to tell it, well, if the type is pet, then actually I probably want to highlight the pet name. If the type is owner, I probably want to highlight the address, if I have a hit in the address. So you need to write a simple bit of code to do that. And actually, one of the nice things about the out-of-the-box Spring MVC controller is that it provides an extension point called basically provides and it has a search helper which implements three methods. Basically, it can build the query, process the results before they get detached, and then post-process the results. And if you can basically just drop your class in to that to the search controller. So, for example, you could write a little trivial class that filters down the search results so that they only search one type of entity. So, for example, if you want to have an employee name search controller, you just use the standard Compass search control, so you don't need to worry about pagination or anything like that. And then you just write a little helper bean that goes filter the search results to where alias equals employee. Unfortunately, I can't really got time to go into sort of detail of how you do it, but it's really not hard. Let's see, what have we got? So, mirroring, I mean, basically, I think we've pretty much covered this. You can mirror stuff synchronously in process, which is what the AOP interceptors will do. You can also do periodic mirroring. This is what you can do with JDBC devices. So with a JDBC device, you can specify the query, so select start from customer. But you can also specify a version query, which basically says, select customer ID and last updated date. And then it will go select all of those and go, right, I need to update these, and then it will know that data's changed, and you can have it basically run on a scheduled basis, so run it every 10 minutes, every hour, every day, whatever, and it will pull in the latest changes. You might need to do some configuration there. Or alternatively, you can roll your own, because the interface is quite simple. You just implement something that, because Compass doesn't really care, you can just throw any data at it. Another thing you might want to do is run indexing asynchronously for performance reasons, because some things, if you're indexing a large amount of text, it may take a certain amount of time to digest and to kind of go down the pipes. If you're throwing like 5 megs of text at it, then it will take 20. It might take 20 seconds to tokenize. So you might want to run that out of process. But so an example of the AOP. These are Spring 1 style. So obviously it's a lot less verbose using Spring 2 style devices, but it's basically very simple. You have your device beams. You give each device beam, you just give it a reference to the Compass instance. Then it's an after returning device, so it just invokes the method, and then when it comes back, it either uses the return value of the method or one of the passed-in arguments for the method, which works very well in most cases. And the great thing there is, of course, you need not write any code or have your business logic aware that